Today I will be discussing this problem. Now this problem is based on the concept of tension force, and we also require some ideas about calculus. So this is a little advanced topic in mechanics. So in this question we have been given a rope that is getting reeled around this circle with an angular velocity of omega. The rope has a mass of m and the length of this rope is L. This rope is fixed at this point. Let us consider it to be A. We are supposed to find the tension as the function of R. So now what is R in this situation? So if you take this rope is fixed at A. Since we are supposed to find the function, we'll take an elementary mass dm. The distance of this mass from point A is R. Okay, this elementary mass has an elementary length of dr. Okay, now we can determine the elementary mass, and that is given by mass per unit length into the elementary length. Now this is the overall mass. This capital M is the overall mass of this rope and L is the total length. So mass per unit length into the elementary length will give you the mass of this elementary rope. Okay, now so why we are finding the mass? Now we need the mass because tension is nothing but a force. Okay, and when this rope is getting reeled, this elementary mass will get pulled in this towards A with the centripetal force. Okay, so at this section of this elementary mass will experience a tension force in this direction such that it is pulling in nature. Okay, let us consider this tension to be T at R. Okay, also this section will also experience some pull from due to this portion of the rope. So let us consider this tension to be Tr plus dr. Okay, now this small elementary tension, okay, if you subtract this two, then you'll get an elementary tension which is acting in this direction because the centripetal force will be acting towards A. So the sign of this centripetal force will be negative in this direction, which is equal to dm omega square r. We know this formula. M omega square r is the formula for centripetal force. So which is equal to this elementary tension experienced by this elementary mass when this rope is getting reeled around this circle. Now we can replace the value of dm, that is m by l dr into omega square r, okay, dt. Okay, now we'll integrate this equation. So dt we'll integrate this equation. We will use a indefinite integral in this case, and we will put the boundary values to find the constant. Okay, now this is equal to m by l omega square. I am taking this 2, this and this are constant, omega is also constant, m and l is also constant, so only the variable is dr, r. Okay, so you can integrate this. Now when you integrate this will come out to be t, and m by l, okay, m by l omega square, this is coming out to be r square by 2 plus c. Okay, now we need to use the boundary condition to find the value of this constant. Now at r equal to 0, So at this point, when this R is 0, at this point the tension is equal to T naught. Okay, or you can say maximum tension will be experienced by this rope at point A. So we'll substitute that value. So this will come out to be T naught equal to minus m by L omega square into 0 plus C. So in this case C is coming out to be T naught. Now the second boundary condition would be at R equal to L. At R equal to L, after this section there is no rope, so there will be zero tension experience by this rope. So at R equal to L, the tension is equal to 0. Okay, now we'll substitute that value again in this equation. In this equation 1, we'll substitute this value again. So 0 will be equal to minus m by L omega square L square. Okay, we are replacing R by L by 2 plus C is nothing but T naught. We have already found in the previous condition. So in this case T naught is coming out to be nothing but m by L omega square L square by 2. Okay, this, if you take this side, it will come positive. Now if you replace the value of T naught in this equation, if you replace the value of T naught and C in this equation, then you will get the value of tension as a function of R. So let us do that. Okay, in this equation we are replacing this. So T is coming out to be, T is equal to minus m by L omega square R square by 2 plus C is nothing but T naught. Okay, and we can put this value of T naught here, minus m by L omega square R square by 2 plus m by L omega square L square by 2. In this case, if you take m by 2L omega square common, then you'll get L square minus R square. Okay, you'll get this equation if you take m by 2L omega square common in this situation. So this is the final equation of tension as a function of R for this situation.